In the previous class, we were looking at remaining concepts in advanced Python programming. So we had already covered some concepts in advanced topics in Python. In the previous lecture, I was able to cover with you regular expression using the regex, generators and iterators, and decorators. So we finished all those concepts in advanced Python topics. Now we're remaining with some two concepts: context manager, multi-threading, and multiprocessing, which we were supposed to cover, and I promise you that I would give you a pre-recorded class that you can follow it at your own pace. So let's dive and cover these concepts so that you're able to understand all these remaining advanced topics in Python, so that in our next class we should be able to introduce Python for data science, deal with data visualization, and then data statistics for data science. We look at descriptive statistics and inferential statistics. So let's start this understanding what context managers are. So when we come to Python programming, these are the only remaining areas that I'm supposed to cover because I've already explained them to you. So we will look at context manager first. And in context manager, all we need to know is an object that defines a temporary context of a block of a code. So let's see. Basically, context manager is an object that defines temporary context for a block of code. We will look at one example how we can implement context manager, and here is how we can. Let's look at example 1. Example 1. Now in our first example, we'll just demonstrate how we can use a context manager. And to make it much easier, the advantages of using context manager, they help us to ensure that resources are released properly, and then they can also make our code concise and readable. They can also help to avoid common errors such as safeguarding, forgetting to close a file, and they can also be used to implement common patterns such as transaction and logging. And if you're working in Python, it's always recommended that you use context manager. They help to make your code more readable and efficient. So let's see how we can look at this first example of context manager. So in this example, we will just implement context manager. So let's implement let's demonstrate a context manager to open a file and return a context manager instance. Okay, so let's start by defining our function. So we can do def, then it will be a context manager. So we use the snake case, create a context manager. So our context manager in this case is going to be open file, and we pass in argument file name in the function. Then let me comment this for you to understand it. So this will open. The next line of code that we will write down is to open a file and return a context manager instance. So how do we implement that? We can just write it. Let's just first declare a variable for file, open file. Then we can pass in our string R. Okay, so to be able to read the file. Now let's now define one function that takes an argument and returns a context manager. The context manager will be a tuple that will enter and exit. So let's see how we can implement this. So let's first define a function in form of a tuple for entering and exiting. So we can define, let us say enter. Okay, we're not self-checking anything. Now what do we want it to return? Let it return our file, which the variable we created here. Then we can have we can define another function for exit that can implement a tuple of exit. So let's see how we can do that. So we can define that function exit. So now we have this exit. Let's put in a tuple list, I mean. So a tuple could be, we could just do self execute type, execute value, and then execute tb, anything, maybe in a table. Okay, we're just demonstrating. Then we can close, we can file close. Okay, now here we can allow it return what it can return for us. It can return enter and exit. Okay, I think that's cool. Now we can leave 2 more lines normally after defining a function. Then you can say width. So the width will help us to read the content of our context file. So with this the width statement uses the context manager to open the file, my file. So we can probably have the file here. So let's use the width statement. So width will open file. So we can pass in to open a file and return a context manager instance. So let's put it as a string, my file dot txt as f. Then we can now create a variable, define a variable contents which can be f dot read. Okay, now in this particular example that I've given you, you can easily see that we were able to define function open file, and then the function takes the argument and returns a context manager. And we also, the context manager is a tuple. Is a tuple of enter and exit. Now, the enter function is called, this enter function is called when the first statement, when this first statement starts executing and is responsible for setting up the resources that are needed for the block of this code here to execute. So in this case, we use the enter function that opens the file that opens the file.txt, file underscore my file.txt. So that is what we use. Then the exit tuple function is called with the statement finish, so that it finish executing, and it's responsible for tearing up the resources where set up by this enter function. And in this case, the exit function closes my file. So the exit function closes my file, and that's how within with the with statement it also helps to close the function. So the context manager is a powerful tool that can be used to manage resources. They can help to ensure resources are released properly, even if an exception is raised. So the different benefits of exception manager: they help to ensure resources are released properly. They make code more concise and readable. They can help to avoid common errors such as forgetting to close a file, and then they can be implemented with patterns such as transactions and logging. So it is always recommended to use context manager. They can help to make your code more readable and efficient. Let us look at one example that we can. This may not run in our terminal because we do not have the file. So even when you try, let's try it out, but I'm sure it won't run in our console. It can't be executed by the compiler. Okay, so you see, you get that no such files, these files are not there. That's why I said, but let's look at one example that we can implement that can be executed by our compiler in the terminal. So this was example 1. Let's look at example 2, demonstrating a context manager. Okay, now this time round we will be able to use let's look at a timing. Let's demonstrate a context manager using a time series. Okay, so this could work. So demonstrate context manager using a time series. So let's first, you looked at the different models, so we can first look at let's import the model for time. Now once we import the model for time, we can create a class this time around we are not using to get the time series. We could probably use time series as our class, but let's define class as a context manager. So in our class, let's define timer to be our context manager by implementing the enter and exit method. The enter method records the start time, and then the exit method calculates the execution times and prints it, so we can have a snippet of our code. So let's do that. Okay, so we can have class timer. So this is going to act as this would be our context manager timer. So let's define, we can initialize the construct. Okay, so let's initialize the enter. Okay, so the enter with the tuple will start. Let's create the variable self dot start time, so equals time. So we created that variable. Now we can define the exit. Define exit. Okay, so the exit, we can pass in a tuple self. We can have execution type, and execution type, I'm using now tab 9 execution type. With our Copilot, it's just trying to auto generate for me. This execution is not yet defined in the pilot value. We will see how. Then we can also have execution type, so we can have a trace back. All right, then I hope this would fix that. So let's look at the end time. The end time. Okay, so in the end time, because we created the variable for end time to execute, so we can do execution time. So it would be end time minus start time. Then we can print. Let's format our string to the time for this execution. Now what we could do, we can pass in within the execution time, so the value of our object, and we can look at the time. Oops, we could look at the time in, let's see if so that time, the execution time can be in seconds. Let's see how it can execute it in the seconds that elapses. All right, now we can define we can use the width, which I explained to you that it helps now to measure the execution time. So let's do let's use with the with example usage. So here you can say with, now with what? With our timer, which is the context manager. Now then this statement measure execution time. So this particular line measure the execution time. So let's see if we can, okay, let's see if we can implement time to sleep like 10, but 10 would be too long. We could reduce it to like 2. Okay, so if we run our output, we should see the execution time. But before we get done, we have expected expression, line 805. Okay, so we need just to confirm this. Did we? It has been this is for exit. Alright, so I think that is it. We have debugged that using that simple way. So the timer class here is defined in this context manager, and by implementing this enter and exit, we will see the time. Using these two methods, we will see the time record that starts and the time record that exits. So this the enter method here and the exit method calculates the execution time, because we trying to look at the execution time, which is end time minus execution time. So it should give us the overall time for this code that you have written to execute. So that's how you implement the context manager. So let's see if this works. It should be able to work. We don't have any error. So just do Python 3, then the file name jeffgeoff.py. You see it takes some times. Oh, traceback error. Okay, local variable, line 810. So we could fix this here, because this error is in this line 810. This module is not there. So we can just do a self dot start time. I think this should fix that. We can debug it using that way, and it fixed that, so it can display that time. Okay, perfect. So it has worked. So the time for this execution is 2 with those floating point values second that has elapsed to execute this line of code. So this is a typical way how you can use context manager in timing. You can also apply it in file handling, and then you can also apply it in other concepts like database connections, but we're not going to look at it because we have to also cover the multi-threading and multi-processing. Now this is done with context manager. Now we're going to go to our last advanced concept that we have not yet covered, which is called multithreading and multiprocessing. We'll try to have examples to help us understand this concept, and once we're done, we clear it out. Okay, we should be able to proceed easily with the concept. So let's see how we can discuss the multi-threading and multiprocessing. So to me personally, when we look at multi-threading and multiprocessing, multi-threading and multiprocessing are two techniques that can be used to improve the performance of a Python program. So I could write this here. Techniques that can be used to improve performance of a program, of a Python program. All right, so that's what we know about multi-threading and multiprocessing, but we could handle it one by one. We could probably look at instead of handling all of it at once, we could handle multi-threading. Is a technique where multiple threads are created within a single process. So is a technique where multiple threads are created within a single process. So that is what multi-threading is. Then we also have the concept of multiprocessing. Multiprocessing is a technique where multiple processes are created. Okay, so the difference here between multi-threading, multiprocessing, basically looking at the multiple threads that are being created, and each thread can run concurrently with the other threads, but also share the same memory space. That means the threads can be accessed and also be modified on the same data, which can lead to raise conditions if not handled properly. Then we also look at which techniques are used. So here are some of the considerations when choosing multi-threading and multiprocessing. When you're dealing with the number of cores in a CPU, so you can probably run that task. Then the type of a task you are running. If you're running a task which is independent of each other, you can use multiprocessing, is better. But if you're running a task that requires multiprocessing and multithreading, so the complexity of multithreading can be more complex to implement than multiprocessing. So multithreading is more complex to implement than multithreading, but we shall see how to implement both of these concepts. And then another thing is that in Python, both of these techniques can be used to improve the performance of a Python program. The best techniques to use depends on the specific task you're trying to use or accomplish. So let's see the task that we are trying to use and accomplish in this situation. Okay, so we'll definitely begin with we will try to see if we can implement multi-threading, multiprocessing, and then use the combination of the two. So we can have our example 3 and then handle those two concepts. So let's handle example of multi-threading. So in this example, we will create a thread thread.thread class. Okay, so let's see how we can do that. First, you need to import the module. You need to import the module for threading. Okay, hopefully I have not left too many space, otherwise I might. Okay, so import threading, then you leave one line, then you define the thread. Okay, now so here we will assign the task to execute concurrently. The threads are started, and then the other thread waits all the threads to finish, then joins the method. So let's see if we can create a multi-thread. So let's see how we can do that. So we can have a task, which is a function. We can pass in a name. Okay, let's terminate that, and we can print, because we want to see the task that is running, print, and we can format our string. We can use the F string to format, so it would be running task. So which task are we running? The task is name. Okay, all right, then now let's create multiple thread. Let's create multiple threads. So how do we create this multiple thread? So we could first have a variable threads, threads, then to hold it would let's hold it's all kind of a list. So let's see how we can implement that. So we can run about 5 threads. So we can use for loop for I in range. For I in the range, which range should we, where it should stop? We could do 10, but yeah, we could do 10. Then so T, which will be our variable for threading dot thread. So threading dot thread class, it's a class that will, let's see our target. So it will target our target should be task that is executing. Then args for arguments, which would be, let's format our string to you could say thread, then we could have the the name for I, because we already for I in thread, so then it would be able to generate that. Okay, let's add a comma because we could want some other processes that can be some thread displayed to be there. So let's try to append something in our thread. So it should append, let's do threads dot append. We just want to add something. We will add the threading processes. Then so we can have our thread dot start. Now how do we wait for when that process finish? We need to wait for the process to finish. So wait for the process to finish before we join. So let's wait for the process for all threads. Wait for all threads to finish before it joins. So we could now use for t in threads, then t will just join, t dot join. Alright, so we expect when we execute this code, because the multi-thread will be created using this threading, okay? Threading dot thread. So let's hopefully we have done it rightly. Let's run and see. Should be like wait for the other thread to finish, then it joins. Okay, so we have a problem in line 837, where we have format thread. That means this is where the problem is. Could fix this by just adding h. Okay, so you see here it has run all these tasks, but there are many. We could reduce this to 5. Okay, so you could see running task thread 0, running task thread 1. So these are the threads that are being executed using this process. So this is the concept of threading. Just like I explained it here, I said clearly that threading is a technique where multiple threads are created within a single process. So we created multiple threads from a single process. Okay, now each thread is running concurrently with other threads, but they all share the same memory space. This means the threads can access and modify the same data, which can lead to condition if not handled properly. So let's look at multiprocessing, a technique which can handle multiple processes. So that is it. We'll look at one more example on multiprocessing, then we can use a combination of the two. So this was example 3. Now let's go to example 4. So example 4 will be, so let's look at example 4, which is going to be, instead of multi-threading, we could now look at multiprocessing. Now in multiprocessing, we will demonstrate here. Let's demonstrate. Use of multiprocessing. So let's see how we can demonstrate use of multiprocessing. We can run all those processes through a pool. Like process, we would first wait for the process to finish, then it joins. So a multiprocess, we can create it using a multiprocessing.pool class. Then with a specific number of processes, we can have about 5 processes. Then the multitasks are submitted to the pool using apply. We shall use some apply.async method, which schedules the task to execute in parallel. This pool is then closed, and then the main process wait for all the processes to finish using the join method. So let's see how we can implement this in a real let's demonstrate use of multiprocessing. So first, when you're dealing with Python, you need to import multiprocessing. Now once you import multiprocessing, just leave one line, then you can now define, let's define a function process. Now the process task name, hopefully we won't forget that we have used process tasks. Okay, so what should be the process task? Let's first have the print, because we really need process task. Print our name with the F string. Okay, so let's use the F string here for formatting. Now let's create a pool of processes. So how do we create let's create a variable for pool, which should be multiprocessing.pool. Now we can pass inside processes. How many processes do you want it to execute? You could do 5. Okay, then for it to submit, so let it submit multiple I just not written the spelling well. It's multiple task to the pool. So submit multiple tasks to the pool. So we can use the for range to loop so that we can have that executed just in the same way we did with the multi-threading. So we can use for I in range. So what should be the range? We could do 6. Okay, we could do 6. Then pool dot, then this is what I was saying, we apply sync to sync the processes. So which is going to be process task, and passing the arguments args, and format our process. So let's process. Okay, then I. All right, then we can close the process after when it's done. Close the pull and wait for all processes to finish. So then we could now join from that point. So we can have pull dot close and now pull dot join. So in this example, a multiprocess is created using this multiprocessing dot pull process. So we have about 5 processes that we want it to execute. Now with this is the pull class. Okay, now then with a specified number of processes which we indicated 5, multiprocess are submitted to the pool using apply sync, okay, which is a synchronous version of apply method. So this method will asynchronize the process and pass in the process start, which we define in the function here, and then pass in our arguments for iteration. And then the pool is then closed, and then the main process wait for all these processes to finish. Then wait for all processes to finish using this join method, and that process is executed. So let's see how it will take the display, the output in our console or terminal. So we've run everything, but literally nothing happened here. Okay, so we could, because let's just change this to process. Probably this might not be detected. Okay. Okay. All right, so that could work for us. So does it mean it doesn't take if we put task? Just wondering. Okay, still works. Okay, so it was just about the indentation, so which we fixed that. So this is how you could see there are about 5 processes that were executed in our terminal, and this is how you use multi-processing, which I've said it here that multi-processing is a technique where multiple processes are created. Each process has its own memory space, so threads in different processes cannot be modified, okay, or access others' data. So the multiprocessing, this makes multiprocessing makes multiprocessing task safer, but it also makes it less efficient. So that's why, to me, it's always important to, depending on the task you want to accomplish, but it's always important to use those concepts based on your complexity of the task. So let's apply these 2 concepts together, multiprocessing and multi-threading, in one example, and see if we can demonstrate these 2 combinations to achieve the task. So I'll comment this out. Now it would be our example 5, and that would be our last example for this concept of multi-threading and multiprocessing. Okay, we might kind of have a longer print to display that output, but I'll see how we can make it much more easier. So in this example that I want us to demonstrate, example 5, demonstrate use of should be use of multi. Let's start with multi-threading. And multiprocessing. So we will have a threading.thread class so that it can create a multiple threading, and then we can use these two concepts together. So first, it's always important to import the modules for. We can begin with the module for threading and then import. This time round we import module for processing. Oops, it's called multiprocessing. Alright, now we can define a task that we want it to execute here. Okay, so we can define that task by saying define. So we can do a function for task. So task in the pool. Okay, so just let's leave it as task. Then we pass argument name, so we can now print. So we can print f format hour running. So it can be running task name on thread. Then we can have on. Cannot have thread, then threading dot current task underscore. Oh, so threading no, can just do this. I always want people to write clean code using pep 8. Okay, it looks longer, so I'll see what to do, but let's first write it all. So we could do threading dot current thread using that threading function dot name. With process. So with process, so what should be that? The process should be multiprocessing dot should be dot current should be dot current process dot name. Okay, this doesn't want that. Okay, so we might have it to go longer because looks like so I'll see if we can format it. Format on save can help organize that particular line of a code, because it's not a good practice to have that long code. written like that. Let's see. Let's create some multiple threads. Create multiple so let's create multiple threads to run. So we could still do threads, which is a variable, then to accept list. Okay, now here we can demonstrate it using for loop for I in range. Which range? Okay, let's just do for range only. For I in for range, then our t variable, which should be trading dot thread. Then the target should be our task. Then we pass in arguments args. So the argument args could take in the tuple f for thread. Okay, I think that is okay. So we can append something in the threads. So threads dot append t. Then we can also have t dot start to start, basically to start. Then when it starts, we have to wait for it to what? For joining. So let's wait for all the threads to finish, then join. So we can now create, let's create a wait for threads, wait for all threads to finish, then for t for thread in threads, then we can do t to join, t join. Okay, this particular line of code is long, but as soon as I just put it here, we just get problems. Okay, let's just leave it like that. That's a long thing anyway, because we are combining all of them. Okay, so let's see if we can have this run in our terminal, because what we basically implemented, we created first you need to import threading and multiprocessing. Then we create a threading class, this class. So each thread is assigned a task to execute within the task function. So we have a task function. Okay, then the process name are printed. The process name are printed within this function task. Okay, so this is a typical example that demonstrates a combination of multi-threading and multiprocessing, and then prints the name of the execution and the process. So this is how we can showcase threading, and let's see if we can implement that practically. So you could see, wow, it has just worked nicely. So running the thread 1 in thread, process 1 in thread. So in this example shows the use of multi-threading to achieve parallel and improve performance in Python. So multi-threading is suitable for I/O, which is input and output bound task. And while the process is effective, this CPU bound task understands the concepts and apply them appropriately. That can that can significantly enhance the performance of this particular code. So thank you for watching or following this pre-recorded class. I believe I've explained. If you feel you don't understand anything, feel free to write back to me on mail. But this demonstrates all these processes. And one other thing is that it also helps you to understand this entire use of multi-threading and multiprocessing. So multi-threading and multiprocessing are techniques that can be used to improve performance of a Python program. They allow a program to run multiple tasks at the same time, so which can speed up the execution of the program. So this multi-threading is just a technique where multiple threads are created within a single process, and each thread can run concurrently with other threads, but they all share the same memory space. So this means that the threads can access and modify the same data, which can lead to, if you don't handle it well, it can lead to, if not properly handled well, it can lead to a race condition. Then multiprocessing is a technique, of course, where multiple processes are created. Each process has its own space thread, so the threads in different processes can access or modify other data. This makes multiprocessing safer than multi-threading. So it's always important to know that multiprocessing is more safer than multi-threading, but it also less efficient. So one thing that you should know, these techniques depends on the type of task you want to accomplish or run. So there are several considerations when choosing multi-threading and multiprocessing: the number of core in your CPU, the type of task you are running, and then the complexity of your code. So those are the different considerations you have to have at the back of your mind before executing this. Thank you for following this episode. In our next episode, we will be covering Python for data science, data visualization, then statistics for data science. And just know that data science is a branch of computer science that deals with storage analysis of data. So these concepts are used quite in a different way, because we will try to understand them. But just know that when we mention data science, also know that machine learning is under data science. But when you're looking at Python for data science, so data science takes also all those aspects of the machine learning. But we'll try to see how we can implement those too. Please, if you will not subscribe to this channel, consider subscribing, like, share, and we grow this. Thank you. See you tomorrow. Peace.